Good afternoon, students. My name is Ananias Akweterera. Welcome to Bachelor of Education and Senior Primary, BESP. I'm going to be your tutor for the module of Natural Science and Health Education 4. So welcome to this exam-based presentation. This presentation is very important because it helps to prepare students for an upcoming examinations. So this content covers most important things that are likely to be covered or might be asked in your exam. So please take look into it, concentrate in the presentations because it will really help you to do best in your exams. Unit 1. Before Unit 1, we have to look into the course outline. Very important. Course outline, it covers 11 units. Unit 1 up to Unit 11. It covers features of metals, ground properties of element, and features of ionic and metallic bonding. Unit 3, different types of materials and uses of materials. Structures and properties of materials, that is Unit 4. Unit 5 is features of environmental chemistry. Unit 6, features of the composition, uses and pollution of air. Features and importance of saving water, that is covered in Unit 7. Unit 8 covers physical features of matter, mechanics and power. Features of energy, conservation and sources is covered in Unit 9. Unit 10 covers features of electricity and magnetism. And the final Unit 11 cover features of waves, sound, as well as light. We commence with Unit 1. It's very important, for us to look into the features of metals. We have solid, liquid, and gases as state of metals. Now, when we are talking about solid in terms of kinetic molecular theory, what are we talking about? What does it specify? Kinetic molecular theory states that solids have little space between their particles. They cannot move freely. They are closely packed together. The particles are tightly, they don't move freely, and they are very strong. However, when it becomes liquid or gas, if the temperature increases. Let's look into compounds, molecules, elements, and atoms in terms of differences. What are the compounds? Compound is a substance composed of different elements that are tightly bonded together in a chemically form, or chemically, not physically, chemically. Molecules, these are smallest particles of an element of chemical compound which can exist in the free state and still have all the properties of that element or for that compound. So what is an element? Element is a substances that cannot be broken down into simpler substances by any ordinary means. And finally, the atom is a smallest particle of an element which can be said to exist or to exhibit the properties of that specified element. We will continue with Unit 1. We have to look into some examples of calculations. For example, you are given carbon relative atomic mass, which is 12.011. So you are asked to determine the percentage occurrence of each of the isotopes if that carbon only occurs as carbon 14 and carbon 12. So we assume that X percentage is carbon 12 and the Y percentage is carbon 14. So this correction is not Y percentage is carbon 12, but Y percentage is carbon 14. We have to use the formula whereby you say 12.01 is equal to X, which you multiply by carbon 12, you add Y, which is unknown, you multiply with 14, carbon 14, and you divide by 100 until you substitute well, calculate well, until you come to the final answer, which is 99.5%. Another example, you are given that lithium occurs as 2 isotopes in the proportion shown in this example. We have lithium 6 multiplied by 7% and lithium 7 multiplied by 93%. So I might ask you similarly to calculate the average mass of the 2 isotopes. So what do? You just add the mass of the 100 atoms together using this formula. Solution: mass of 100 atoms is equal to 6. You multiply by its percentage. You add to lithium 7, which is multiplied by its percentage, which is 93%. Then you get your answer, which is 6.93. That's the final answer. Mass for the isotope. And before you continue, 693, which is 693, is divided by 100. That is how you come up with 6.93, which is a mass of 32 isotope. We continue. Let us look into Unit 2. Groups, properties of elements, features of ionic and metallic bonding. Let us look into the characteristics of boiling point. Boiling point is a temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. Depending on the atmospheric pressure, different substances might have different boiling point. For example, water boiling point is 100%, but other substances might have more than that or less than that. And to be specific, boiling point is a physical change because it is a temporary change or it is reversible. For example, after you boil the water, you can also turn it into ice by freezing it. So that is physical change, and it's not chemical change. Thank you. Let's look also into another calculations. I might ask you, calculate the relative molecular mass of H2O, which is water. This one is calculated by the given formula, which is Mr. You multiply just by water itself, H2O. So 2 hydrogen, you multiply them with their mass plus 16 for oxygen. That is the mass. Then you get the answer, 18.02. Let's look into 3 types of covalent bonding. There is simple covalent bonding, single covalent bonding, double covalent bonding, and triple covalent bonding. This kind of bonding, the main difference is how many electrons they are sharing when the reactions or the bonding is taking place. For instance, single covalent bonds occur when each atom shares only 1 electron and attain a noble gas status. Specifically, this occurs when a hydrogen atom has 1 valence electron. When 2 hydrogen atoms collide, their valence overlap, then the 2 molecules form a molecule, and that is what we call single covalent bonding. Double covalent bonding, it involves the shares of 2 paired electrons, and the triple covalent bonding, it involves 3 shared of pairs of electrons. That's the main difference, and that is how they are. Please take note of that. Unit 3, different types of material and uses of those material. We have natural materials and synthetic material. Natural materials, these are materials that are found in nature. For example, aluminiums, stones, trees, those kind of materials. Those are natural, they are natural. And synthetic materials, these are materials that are made by human beings. For example, plastics and other materials that are made in factories or everywhere by human beings. Now let's look into the properties of metal. Metals, they are good conductors of electricity. These metals, they can also be, they are malleable, which means they can be hammered into different shapes based on the users' or customers' preferences, and they can also be turned or can be stretched into thin wires without them cracking or breaking. That is best. That's one of the best of their characteristic. They are used in electric wires, making pots and pans because of their characters of good conductors of electricity. Unlike wood, for example, when people make pots, they use wood for handling because it cannot conduct electricity, and this is just to prevent electrocutions. But metal itself, it is used overhead on the pots or other things because it conducts electricity. It's also good in terms of linking sound. That's why it's used in many things like bells and other things. Unit 4, structures and the properties of material. Let's look into the properties of nylons, because we use nylons. It's used in many industries, households, and many places. So what are the properties of them? Plastics, they are very resistant to heat. They are chemical resistance. They are flexible and durable, and they have also what we call low friction. And that's why, for example, in laboratories, the personal protective equipment, like let me say gloves and other things, uniforms, students, they have to put on those are plastics one to prevent any chemical spill. Let me say hydrochloric, maybe to spill on a student's hand or and so forth and so forth. That's why it is a good chemical resistant. Let's look into non-biodegradables and biodegradable properties of products and their impact on the environment. Biodegradable describe materials which can be broken down by decomposition processes by fungi or bacteria. And when they are decomposed, these are good food for the plant to grow and also keep the ecosystem running. However, the biodegradable products can do harm to the environment, because if we produce a lot of them, they will end up in the landfill, they take up our space, and they also likely to produce methane, which is a very dangerous gas, which might affect human beings who are working on the landfill when it comes to maybe during sortings of products or cleaning of landfills and other things. And this gas can also just turn into the fire, which can also burn up the environment and disturb the biodiversity. Non-biodegradable. These are materials which cannot be broken down by decomposers. The long-term exposure to air, light, water can cause synthetic material like plastics to emit toxic pollutant, which might also affect a human being. And constant exposure to heat melt plastic, emitting gases into the atmosphere is also a process known as outgoing gases. And some of these non-biodegradable material might release dangerous gases that are contributing to or part of greenhouse gases that might contribute to global warming, that might affect our world at large. So what are the advantages of using fiber in fabrics? Because we have many different fabrics even in our country. So the advantage is that fibers are good insulations. Durable, they are very cool. Dyes well are absorbent, easy of laundry, and they are very economical to use. They have few wrinkles, they are resistant to abrasions and tearing. So that's why they are very good, and they are very useful when to use in fabrics. Unit 5, we are looking into features of environmental chemistry. There are 3 types of decomposition reactions. So let's look into what types of chemical reactions, what happens during the process of each decomposition or each types of chemical reaction. Pardon me, not decomposition, but types of chemical reaction. Decomposition reaction. This is a simple single compound breaks down to give more simpler substances. During a decomposition reaction, there is a change in number of molecules. However, the total number of atoms and mass involved in the chemical changes will not change. For example, leftover food, when they are dumped, let me say on the ground, they decompose or they are destroyed by fungals or bacteria into manure, and that is what you call decomposition reaction. Synthesis reaction. During this reaction, reactant react to form a new product. When an ion gets rust, a synthesis reaction is taking place. The ion react with oxygen, for example, to form rust, and this is mostly happening at our coastal area. Because metals, if they are exposed to the gas, let me say oxygens, and fog, those kind of things, they react. And that is what we call iron oxide reaction, which is rust. And that is what happened during synthesis reaction. Exchange reaction. Ions are atoms or group of atoms that bear positive or negative charges. So in a pair or other multiple, they make up substances of many crystalline materials, including table salt. Certain insoluble materials bearing positive and negative charges on their surface react with ionic solutions to remove various ions selectively, replacing them with ions of other kinds. Such as reactions are called ion exchange reaction. For example, if you add chlorine to water, to treat water, what will happen is exchange reaction when you are treating water. That is what happened, and that's how it is called. Unit 5, continue. Let's look into the difference between acids and alkaline. What are the acids? Acids, they are liquid. They are solutions of compounds in water. It contains concentrated, if concentrated, they are corrosive, very corrosive. And they can even destroy human skins when not handled properly. Acid taste sour. They contain hydrogen ions. This acid, they have a pH of less than 7. And any pH which is more than 7 is alkaline, and 7 itself is neutral. Now, what are the alkalines? These alkalines, they feel soapy to touch. They are soluble bases, like acid. They can also bend skins sometimes if not handled properly. They contain hydroxide ions, and unlike acid, which contain hydrogen ions, and they taste bitter. So that is their main differences, and please students take note of that, because these ones are also likely maybe to be asked in exam as well. We continue with Unit 5. with physical and chemical changes of substances. What are chemicals and physical changes of substances? Physical changes, a change which results into no new chemical substances being formed. Physically, change is accompanied by a change in arrangement of particles, the absorptions or release of energy. For example, if we combine sand with water, that is what we call physical changes, because there's nothing like chemical reactions happening. They can also be easily separated, let me say with filtrations or other things. So that is what we call physical change. That's how it happens. Chemical changes, these involve chemical reactions. For example, if you add hydrochloric acid to something, to another reactant, it will come up with, or chemical reactions might happen. Or for example, you mix salt with water. Obviously, dissolving, it will happen, they will dissolve and chemical changes will happen, and you can only probably separate them with simple distillations and other processes. Let's look also into different types of equations. We have equations that happens, or reactions that happens between weak acids, strong alkaline, weak alkaline, and even the reaction which involve acids and bases. So students must be able to at least to know them and to be able to complete them. Should I probably put them in exam and I say, complete this following example of equations between, let me say, strong alkaline or weak acid. For example, strong acid, hydrochloric, it gives out hydrogen and chloride. Reactions between which involve acid and base, for example, sodium hydroxide plus hydrochloric acid, it will give sodium chloride plus water. So students must be able to just solve that out as well. Unit 6, features of the composition, uses and pollutions of air. What are the uses of carbon dioxide in real life? Carbon dioxide are used as dry ice, in soda water, in baking soda, in fire extinguisher, and as a cooling agent. For instance, in fire extinguisher, carbon dioxide is not supporting burning. So that's why it is used in fire extinguisher, to extinguish or to suppress the fire. It's also a cooling agent because this carbon dioxide can cool at a very, very low temperature. What about the use of oxygen in real life? It's used in hospitals, especially this time of COVID-19. A lot of patients, they are suffering and they really need the oxygen supplement. That's why oxygen is used in hospital, in ICU departments to provide the oxygens. It's also used in welding industries, and it's also used in making steel. All right? So let's look into source of smoke pollution. The sources of solutions include, and not limited to, factories. We have a lot of factories that produce smokes, refineries, motor vehicles, especially in Namibia, let me say capital city, Windhoek. They have a lot of transports that are likely to produce smokes. Burning of firewood, forestries is also one of the things which contribute to smoke pollutions in our environment. And also cigarette smoking, it also contributes. And these gases are very dangerous because they contribute to greenhouse gases which affect or might contribute to global warming. And some of them, they also contribute to acid rain, which also destroy our plants, destroy or disturb our habitats and environment. Unit 6, let's look into respiratory diseases which are caused by this kind of pollutions which we just discussed now. We have asthma, bronchitis, allergies, emphysemas, lung cancer, coughing, shortness of breath. Like nowadays, a lot of cases of cancer, they are recorded in our public and private hospitals, and they are likely to be attributed to air pollution. What are the positive ways of decreasing these air pollutions? Student takes note that these points which are given, they are not the only points which can use to prevent air pollutions. There are a lot of points, but they are not limited to, let me say, reduce burning of woods and coals. Let us use catalytic converters on cars and in factories, because these catalytic converters, they are really recommended. They are good. They filter out the pollutants before they are released in the environment. So you are likely to find them in cars and factories, and they are really recommended. And you can also educate and empower people in communities, in schools, in churches, to take ownership of their environment and enhance them, not just to pollute their environment, because if they destroy their environment, their trees and environment and other things, rainfall is pattern is likely to be disturbed, and they are likely not to have a good yield of productions. They are likely to be affected in terms of their air they breathe in. So it's really important to take care of our environment. Therefore, we must decrease air pollution. Unit 7. Features and importance of saving water. What are the main differences between changes that take place in the water cycle and those that take places in nitrogen cycle? In water cycle, it involves physical changes. For example, precipitations. It involves also condensations and many more. While nitrogen cycle, it involves nitrogen fixations, whereby nitrogen is released from the environment into the water and into the soil. That is their main two differences. So what is industrial fixations of nitrogen? As I discussed the area about fixations of nitrogen, industrial fixation of nitrogen refer to the reaction used in industry whereby nitrogen gases from the atmosphere is utilized to produce nitrogen-containing compound. Chemicals versus hydrogen bond in water. Hydrogen bond is a weaker bond between two water molecules. The oxygen atom in one molecule and the hydrogen atom in another water molecules are attracted to each other, and hydrogen bond. While a chemical bond is a water molecule in the strong. A chemical bond is a water molecule which is a strong bond between a hydrogen and an oxygen atom, which is inside. Take note, which is inside a molecule of water. We are almost there, student. Please don't get tired or exhausted. Unit 8, physical features of matter, power, and mechanics. Let's look into potential energy. Potential energy. Why we are saying potential energy? What is potential energy? Potential energy of an object can be considered as a stored energy, because if the object can retain or keep its energy or into the system for a longer time and only use it when it's necessary, then that is what we call potential energy. For example, water in a hydroelectric dam is stored for a long time until it is used. That's why it's referred to as stored energy. Let's look into another example of calculations. I might ask you, calculate the gravitational potential energy of a kiloliter of water with a mass of 1,000 kilogram in a dam relative to a turbine of 100 meters below it. How do you answer this question? The gravitational potential energy is equal to mass times gravitational force times height. Then you get the answer, which is 890 kilojoule. Let's look into the different types of pressure and pulley. Pressure is a force acting per unit area, while pulley are the series of moving wheels and ropes, chains, or wires used to gain a mechanical advantage. So pulley, it helps in reducing pressure. Pulley make work easier. For example, instead of carrying something which is very, very heavy, you tie a rope on the object through the pulley and apply a little pressure, then you get the job done. Unit 8, sample calculations again. A number of athletes are competing, let me say, in a 100-meter race. So you are asked to calculate average speed of a sprinter who completed a 400-meter race in 53 seconds. The formula for calculating this is average speed, which is distance divided by time. You use that one, you put in the distance and the time, then you get the answer. The following calculations, for example, you calculate average speed or calculate how far a person can travel. You can use the same formula, but importantly, student, you must be able to make each something you are asked to calculate, let me say distance or time, as a subject of the formula. Then you just substitute in, putting in what you are given. For example, if I say calculate how far a car travels in 30 seconds at 15 meter square, a meter per second, you just have to make distance as a subject of the formula, which is equal to average speed times time, then you get the answer. Okay. Unit 9, future of energy, conversion and sources. There are 5 processes by which energy are converted from one form to another: solar energy, tidal energy, geothermal energy, wind energy, as well as hydroelectric energy. Solar energy, this is energy from the sun. The solar cell has the ability to convert light energy from the sun into the electric energy. The energy in a solar cell can be stored for a short period so that they can provide energy at night. Solar powered cells last for a long period and pollution free. So that's why they are really good, they are really important, because they cannot pollute our environment, and they are also it's also a renewable source of energy, because we have the sun, which is coming every day, and like that. Tidal energy, this one, depending on the movement of water from the river to the sea or to the ocean, the electricity is generated, whereby the electric or the motor or the generator is pressed into the water, running water, then it makes the generator to generate, and in that way it forms electricity. While the geothermal energy, the pipe which is carrying cold water, they are placed into a hot rocks, and with that, the hot rocks make the water in the pipes to make steam, and that steam make the generator to generate electricity, and that is how it's formed. And the wind energy, the wind turns the blades of, let me say, a windmill, for example, and with that, it turns the generator, which generates then electricity through that motion. While hydroelectric energy, this one depends on the falling water, whereby when water is falling from the higher level to the low level, it runs on a high speed, and then the turbine is driven. When it's driven, it generates electricity through electrical generators. Let's look into the advantage and disadvantage of renewable energy sources. Renewable energy sources, they can be used over and over again. That is the advantage of them. They cannot pollute the environment. They are also affordable. Unlike non-renewable energy, which can be replenished or finished, they are also expensive sometimes, and that is why we need to focus on renewable energy sources. For example, solar system, wind energy, because wind is always there. Yes. However, these natural or renewable energy sources, they can also be affected by nature. For example, if there's no wind, sufficient wind, let me say one day, and then you are using, for example, wind energy, so it's likely not to be affected. Then you want to produce sufficient electricity. Unit 9, we continue. Let's look into advantage and disadvantage of non-renewable energy resource. This was already covered by the previous slide when I summarized them, so we don't have to go through that one. Let's just look into the law of energy. The law of energy states that energy cannot be created or destroyed. It can only be changed from one form to another. That is the law of energy. Let's look into features of electricity and magnetism. There is magnetic north pole and geographical north. Their differences are: the magnetic north pole, it is where the Earth's magnetic field is perpendicular to the ground, right? While the geographical north pole is the point on the surface of the Earth itself, where lines of the Earth's axis of rotation meets the Earth's surface. Alright, I hope we are together there. Let's also look into another calculations. For example, calculate the current in the circuit if an amount of charge is equal to 45 moves past a point in a circuit in a second. Using the formula for calculating current, which is current is equal to energy over change in time, you calculate that one, then you get your answer. Okay. Direct current versus alternate current. Direct current is a current that travels just only in one direction. It cannot reverse clockwise or anti-clockwise. If it is clockwise, it's only clockwise. It's only moving in one direction, not vice versa. Unlike alternate current moves from one direction to the other direction, depending on wirings and other things. So it can move clockwise and anti-clockwise. So it changes direction. That is the difference. And how about terms magnetic field? Magnetic field is a region in a space where another magnetic or ferromagnetic material will experience certain force. We continue with unit 10. What is the relationship between current, resistance, voltage in conductors and circuit? An electric circuit is formed when a conductive path is created, which made sure or it allows free electrons to continuously be in motion. This continuous movement of free electrons through a conductors of circuit is then what we call current. The force motivating electron, the force motivate or enhance or ensure that electrons flow in a circuit, and then that is called voltage. Voltage is a specific measure of potential energy that is always relative between 2 points. When we speak of certain amount of voltage being present in a circuit, we are referring to the measure of how much potential energy exists to move electrons from one particular point in that circuit to another particular point as well. Free electrons tend to move through conductors with some degrees of friction or opposition to motion. This opposition to motion is more properly called resistance. However, the amount of current in a circuit depends on the amount of voltage available to motivate electrons and also the amount of resistance in the circuit to oppose electron movement or flow. We continue. The nature of magnetic field. The magnetic field is a region in space where magnetic or another object made of a magnetic will experience a non-contact magnetic force. You continue with Unit 10. How a generator generates electricity. It all has to do with magnetism. A coil of wire passes through a magnetic field, which will induce an electric current in the wire. So a generator has two basis parts, namely a magnetic for the magnetic field and a coil wound around the shaft. The shaft with coil wound around it is the magnetic field. Importantly, no magnetic or no electricity is produced until the shaft with the coil starts to turn. When it turns, electricity is generated. Unit 11, the last unit, we look into features of wave, sound, and light. What are the types of light when it falls on the different objects that are translucent, transparent, and aqueous? Transparent object, it let light to pass through it clearly, 100%. While translucent object, those are objects that allow just certain light to pass through it, but not 100% clearly. And opaque object, for example, trees, those are objects that do not allow a light to pass through them at all. Properties of sound and wave, sound wave. We have pitch, loudness. A pitch is how high or low sound is and depend on the frequency of the sound. For instance, if you pluck two quitter string, the one that vibrates with a high frequency has a very higher pitch. Take note of that. Now, loudness is related to three factors. One, amplitude, sensitivity, and tone of musical instrument. For example, an amplitude is a sound with a large amplitude sound louder than one with a smaller amplitude, right? Sensitivity of the human ear it will depend on human ear, because some people they are more sensitive to certain sound, etc. Difference between short and long-sighted person. Short-sighted people, those are the people who are only able to see at a shorter distance, and longer-sighted people, those are people who are able to see objects clearly when they see it at a distance, and when they see it at a short distance, they are likely not to see. With this, we end our presentations. I hope it was very helpful for you to prepare for exam. Please go through this presentation. It will be helpful to you. I wish you all the best with your academic endeavors, and have a good day. Thank you, my student.